Hi class, how are you today? That's amazing! The learning target for today is to graph linear equations in slope-intercept form. For the scale, you're a 3 if you can graph linear equations in slope-intercept form, including special cases. You're a 2 if you can graph linear equations in slope-intercept form, so not including the special cases. You're a 1 if you can graph linear equations in slope-intercept form, but you have to use a table. And you're a 0 if you cannot graph linear equations in slope-intercept form. Let's get started.
Alright, so the first thing we'll talk about is that most graph equations you'll see are written in what's known as slope-intercept form. And it's like this: y equals mx plus b, where m is your slope and b is your y-intercept. Now you may ask, where do x and y come into this? What are they? What do they stand for? Well, y is known as the dependent variable, and x is known as the independent variable. We say this because x is the thing that can always change. You plug a number into x and you get out a y. So whatever your y is depends on what your x is. So x is your independent variable. It can be whatever it wants to be. And y is your dependent variable. The value of y depends on what you have in there for x. So let's look at this equation now. We have y equals 2x minus 3. There are a couple different ways you can look into graphing. The first way that we'll look at is with a table. And we want values for x and y. So like I said before, the x is your independent variable. It can be whatever you want it to be. So let's pick some numbers. I'll just go with some easy ones: 0, 1, and 2. I prefer easier ones because once we put them in, they'll be easier to graph. And then we plug this in to the equation up top here. So if we plug in 0, we will get 2 times 0, because 0 is now x. 2 times 0 is 0, and 0 minus 3 is negative 3. Same thing for 1. 2 times 1 is 2, and 2 minus 3 is negative 1. And 2 times 2 is 4. 4 minus 3 is 1. And then we would plot those on the graph. Another way to do it is by looking at your slope and your y-intercept. So remember, as I just said, your slope is the number before the x, the 2 here, and your y-intercept is the number by itself, negative 3. It's minus 3, but we say that it's negative 3. So the first thing you want to do is look at your y-intercept. It's negative 3. So on your y-axis, and remember, your vertical axis is your y, your horizontal axis is your x, and on the y-axis you plot negative 3. Then you look at the slope, which is 2. Anytime you have a number in front of x, you think rise over run. So you want to look at this as a fraction. So we'll put this over 1, because any number by itself is over 1. Then it's rise over run. So we go up 2 and over 1. And then we'll do it one more time. Up 2 over 1. Notice that the points we made, 0, -3 here, is 0, -3 here. Here we have 1, -1, 1, -1, and 2, 1, 2, 1. So they'll give you the same points either way. But it's good to always see the differences that each style uses. One is looking at what's the slope, what's the y-intercept. Other is looking at what happens when you plug in certain numbers. Now with these equations, we're always going to have a line. So connect the points and draw a line. And make sure you put arrows on the end to show that the line goes on forever in both directions. Alright, so the next thing I want to talk about is, what if you have an equation here, like y equals 5? We're missing something. There's no x. X is not there. What do we do with it? So, there's two things we can do. Again, the first thing we can do is a table. So we take our points 0, 1, and 2. I like using the same ones all the time because they're easy. So we have that. Well, when x is 0, what is y? Well, we see here y equals 5. Okay. So when x is 0, y is 5. What about when x is 1? Well, again, let's look. Y equals 5. Okay. That means once again we have y is 5. What about when x equals 2? Again, y equals 5. So every time, no matter what x is, we're going to get 5 every time. No matter what we put in for x, we'll get 5 because x doesn't do anything to this problem. It's not there. Y is just always 5. Another way you can look at this problem is back with our slope and y-intercept deal. Well, remember that the y-intercept is the number that's always by itself. Well, we have a number by itself here. It's 5. So our slope is the thing that disappeared. So what makes things disappear? Well, the number 0 makes things disappear. So this is the same thing as writing y equals 0x plus 5. So our slope is 0. There's no slope. The slope is 0. So we can graph this like we did before, and we looked at our y-intercept, and our y-intercept is 5. So on the y-axis, we'll plot 5, and our slope is 0. So that means we go up 0 and over 1. Up 0 and over 1. So every time, we're making more dots and they're all next to each other. They're all on the same horizontal line, meaning our line will be a horizontal line. So we draw our line, put our arrows on it to show that it goes on in both directions forever. And every time you have y equals just a number with no x, it'll always be just a horizontal line, because it's saying y equals 5. So no matter what x is, on your y-axis, y will always equal 5 every time. So the y will always be 5, and you can follow that along as long as you want. So the last thing I want to talk about is, what if we have x equals a number? So here we have x equals -3. So this time the y is missing. So this changes things up just a little bit. That's because if we try to draw our table like we did before, we can't pick x anymore because x is always -3. So we can't pick 0, 1, 2 like we did before. X has to be -3. So that means our y is the thing that's going to change. So our y will be 0, 1, and 2. This is a special kind of equation, a special kind of function, and we'll talk more about this later. But for right now, let's graph our points that we have here. So we're always at -3 on the x, and then we have 0, 1, and 2. And then we make our line. Again, marking the arrows to show that it goes on forever. So when you had y equals a number, it gave you a horizontal line. When you have x equals a number, it gives you a vertical line. And you may have noticed that I didn't show the other way that we use to figure this out, about slope and y-intercept. Well, that's mostly because we don't have either. The line we have is vertical, so it's parallel to the y-intercept, to the y-axis, so that means it'll never touch. So there is no y-intercept here, and also we don't have a slope. There's no slope. It's a straight up and down line, and we actually call this an undefined slope. So this is a special kind of equation where it sort of switches our dependent variable and our independent variable, and we actually say that it's technically not even a function at all, but we'll talk more about that when we get talking about functions.
Alright, now time for the sponge activity. All I have for you today is to graph each equation. Number 1, graph y equals 3x minus 1. And number 2, graph y equals 5. Alright, that's it for the lesson. Once again, please make sure to take notes on the entire lesson. Please make sure to take pictures of everything, including the sponge, and turn it all into Doodle Classroom. And have a good night.